So the idea here is to actually first calculate what is on the left hand side of your equation. Then after that, you calculate what's on the right hand side of your equation. But one thing that I would advise you guys to do is always start by dealing with the side that is complicated. If the side is complicated, start with it. If the side is complicated, start with it, and end with the one that is not complicated. In our case, if by looking at the equation we can see that the side that is complicated is the left hand side and the right hand side is not. So some people might be confused, why am I saying right hand side? What do I mean by that? So you see this equal sign. If I'm looking this side of the equal sign, that's the right hand side. If I'm looking at this side, that's the left hand side. Just to clarify things. Sometimes when we have equations that are like this, you might find that you have both of the sides complicated, and in that case you can start with either side. So right now let's start with the left hand side. So as I said, trig identities and reduction formulas are very useful in this section of trigonometry. We would have like an expression, but one thing that I would advise you guys to do is to focus on each function all the time. So as we can see here, we have 4 of them again, right? So let's try to do that. Let's focus on each function at a time. Don't look at the whole thing, because if you do that, that's when you are confused. So for A, how can you simplify sine theta any further? We can't simplify sine theta any further. It's just going to be sine theta, right? And if you look at B, let me just say this is A, this is B. If we look at B, if you have cos theta and sine theta, can we simplify this to be something that is even reduced, even more? Not really. We can leave it the way how it is. So this is going to be cos theta sine theta. And C, cos theta again, we can't do anything on cos theta. It's just going to be cos theta. Then D, if we look at now, 1 minus sine squared theta. We know something about this. So remember, when we have cos squared theta plus sine squared theta is equals to 1. Then we found out that cos squared theta is equals to 1 minus sine squared theta. So we can use this fact to substitute for 1 minus sine squared theta. So this becomes cos square theta, right? So if we go back to our equation, we can substitute now. So sine theta, we said we're going to leave it like that. Sine theta minus cos theta multiplied by sine theta. Then cos theta, we're going to have cos theta minus 1 minus sine squared theta is equals to cos squared, right? So this becomes cos squared theta. And now if you look at your denominator, let's start with the numerator. If we look at the numerator, if we take out what is a common factor here, there's a sine theta and there's a sine theta. If we take out a sine theta, we're going to be left with 1 minus cos theta. And on the denominator, if we take out a cos theta and a cos theta here, we're going to have cos theta outside the bracket. Then you're going to take out a cos theta here, we're going to be left with 1. You take out 1 cos theta on the 2 of cos thetas we have here, you're going to get minus cos theta. And if you look at that, you can see that this at the denominator cancel, on the numerator cancels with that on the denominator. Then we're going to be left with what? We're going to be left with sine theta out of cos theta. And we know from trigonometry so far that sine theta out of cos theta is what? It's tan theta. So now you can see we got the right hand side. Therefore, we can say the left hand side is equals to the right hand side. So you did prove that. Thank you guys.